This is still an addition subtraction problem, so we still need to have like terms, which means we still have to start off by simplifying these radicals. And you really have to make sure you don't let yourself get intimidated by all these letters and numbers, because we're just going to take it one step at a time. For the numbers, we're going to try to find the biggest perfect squares we can that divide them evenly, because these are simple square roots. And then, again, since it's simple square roots, we'll just try and make sure we have even powers on these. So I'm going to explain this part pretty thoroughly and do this whole part, and then I want you guys to pause the video and try this part on your own. So if I was tackling this, anything on the outside, I need to keep track of it, but I don't want to think too much about it. So I'm going to type down that 3 and that x. And then on the inside, for the coefficient, I want the biggest perfect square that goes into 12. That's 4 times 3. I want this to have even powers, so I can go to x squared times x to make it x cubed. And then for the y to the 5th, I want a y to the 4th times a y, so that I have an even power, and then these multiply to make y to the 5th. Now when I go through to square root this stuff, on the outside I already have that 3 and that x. The square root of 4 I know is just 2. The square root of x squared is like, what would I square to get x squared? I would square an x. And then the square root of y to the 4th, what would I square to get y to the 4th? I would square y squared. Right? Y squared, if I square that, I get y to the 4th. And then anything that's left inside is left inside. So this 3, left inside. This x, left inside. This y, left inside. And then these, I'm going to do what it says. It says to multiply them. So that means for the coefficients, the 3 and the 2, multiply those together to make 6. X times x makes x squared, and the y squared had no friends. And then we have a square root of 3xy. So that's what happens to this whole left side. You guys pause the video and try and do this side yourself as well, and then we can see about if we can actually add these things together or not. So now that you've had your video paused, we know the outside's negative 5 x squared y squared. 27 I can break up as 9. That's the biggest perfect square that goes into 27. There's 3 left, and an x and a y. So there's no powers on these, so we won't have to worry about breaking this down any further. This stuff's on the outside. Oh, there's this x squared on the outside. I feel better. Square root of 9 is 3, so I have negative 5 x squared y squared. The square root of this 9 is times 3, and everything else is stuck on the inside. Square root of 3xy. Cleaning this up, it's a multiplication problem, so 5 times 3 makes 15, so I have negative 15 x squared y squared, square root of 3xy. Now the last step is just to look at this term and see if they're like terms. And basically, if the variables and powers are the same, if the radicals are the same, and what's inside the radical is the same, then they're alike. But if any part of that is different and it's simplified as far as you can, then they're not alike. So since these both have x squared, these both have y squared, they both have a square root of 3xy, they are like terms. And I'm going to treat this the exact same way I might treat a problem like 6a minus 15a. It's just that instead of a's, it's this crazy bit of business. So 6 minus 15 is negative 9. So our final answer will be negative 9 x squared y squared, square root of 3xy. So this is just kind of jumbling up a bunch of different problems. And we have the simplification going on, we have some powers of exponents going on, we have combined like terms going on. I will say kind of a big hint is, if you're not getting like terms in the problem, then you're probably doing something wrong, because they're definitely going to want you to be able to add and subtract at the end. If there's like 2 or 3 of these, if there's 3 or more of these in one problem, if you have 1, 2, and then other ones, then they may not all be alike, but you should definitely be combining some things at some point. So good luck with that.